Article 517 requirements do not extend to the area above the ceiling for circuits feeding the required receptacle of a rooftop unit. The definition of a patient care area in Section 517.2 of the National Electrical Code states that it is any area in which patients are intended to be examined or treated. The area above the ceiling is not an area where patients are intended to be examined or treated, so it is not considered a patient care area. Additionally, Section 517.16 requires that all circuits serving patient care areas be ground fault circuit interrupter protected. However, 517.16A3 states that this requirement does not apply to circuits serving equipment located outside of the patient care area. The area above the ceiling is outside of the patient care area, so the circuits serving the required receptacle of a rooftop unit do not need to be ground fault circuit interrupter protected. To elaborate further, it's crucial to understand the intent and scope of Article 517 within the National Electrical Code. This article is specifically designed to address the unique electrical safety requirements within healthcare facilities where the risk of electrical shock to patients and staff is heightened. The NEC defines various types of patient care areas, each with its own set of regulations regarding wiring methods, grounding, and equipment. The fundamental principle is to minimize leakage current and ensure a reliable power supply to critical medical equipment. Considering the specific scenario of a rooftop unit's receptacle circuit, the primary question is whether the area above the ceiling where the circuit conductors are located falls under the definition of a patient care area. The NEC clearly defines patient care areas as locations where patients are examined or treated. This includes areas like operating rooms, intensive care units, examination rooms, and therapy areas. The NEC differentiates between general care areas, critical care areas, and other spaces within a healthcare facility, each having specific electrical requirements. General care areas have basic electrical safety standards, while critical care areas, where patients are subjected to invasive procedures and connected to life support equipment, have much stricter requirements. Given that the area above the ceiling is not a location where patients are directly examined or treated, it typically does not fall under the definition of a patient care area. This means that the specific wiring methods and grounding requirements outlined in Article 517 for patient care areas do not apply to the conductors located above the ceiling. However, it's important to ensure that the wiring methods used above the ceiling comply with other applicable sections of the NEC, such as those related to wiring in concealed spaces, support of cables, and protection against physical damage. The exception mentioned in Section 517.16A3 provides further clarification. This exception states that circuits serving equipment located outside of the patient care area are not required to be ground fault circuit interrupter protected. The rationale behind this exception is that equipment located outside of patient care areas poses a lower risk of electrical shock to patients. In the case of a rooftop unit, the equipment itself is typically located outside of the patient care area, even though it may serve to provide heating, ventilation, or air conditioning to patient care areas. Therefore, the circuit feeding the receptacle for the rooftop unit is not required to have ground fault circuit interrupter protection, provided that the receptacle is also located outside of the patient care area. It's crucial to note that this exception does not eliminate the requirement for ground fault circuit interrupter protection in other areas where it is specifically required by the NEC, such as in wet locations or for receptacles serving certain types of equipment. The NEC also addresses the requirements for essential electrical systems in healthcare facilities. Essential electrical systems are designed to provide backup power to critical areas and equipment in the event of a power outage. These systems typically include emergency power systems and critical branch systems. The requirements for essential electrical systems are outlined in Article 517 as well as in Article 700 and Article 701 of the NEC. When considering the rooftop unit and its receptacle circuit, it's important to determine whether the unit is considered essential equipment. If the rooftop unit provides essential services, such as ventilation for an operating room, its circuit may need to be connected to the essential electrical system. This would ensure that the unit continues to operate during a power outage. The determination of whether a particular piece of equipment is essential is typically made by the healthcare facility's engineering staff or by a qualified consultant familiar with the facility's operations. In addition to the NEC requirements, it's important to consider any applicable local codes or regulations that may be in effect. Local codes may have additional requirements or may modify the NEC requirements in some cases. It's always a good practice to consult with the local electrical inspector or building department to ensure compliance with all applicable codes and regulations. To summarize, the requirements of Article 517 do not typically extend to the area above the ceiling for circuits feeding the required receptacle of a rooftop unit, provided that the area above the ceiling is not considered a patient care area and the equipment served by the circuit is located outside of the patient care area. However, it's important to comply with all other applicable sections of the NEC and any local codes or regulations that may be in effect. When working on electrical systems in healthcare facilities, it's essential to have a thorough understanding of Article 517 and other relevant sections of the NEC. It's also important to follow safe work practices and to use appropriate personal protective equipment to minimize the risk of electrical shock. The National Fire Protection Association, or NFPA, publishes the National Electrical Code, which is updated every 3 years. It is important to stay up to date with the latest edition of the NEC to ensure compliance with the most current safety standards. The NEC is a comprehensive document that covers a wide range of electrical topics. It is divided into chapters, articles, and sections, each addressing a specific aspect of electrical installations. Navigating the NEC can be challenging, but it is essential for electrical professionals to be familiar with its structure and content. One of the key concepts in the NEC is the concept of listing and labeling. Listed equipment has been evaluated by a third-party testing laboratory and found to comply with applicable safety standards. Labeled equipment bears a mark or label indicating that it has been listed. The NEC requires that all electrical equipment be listed and labeled, unless it is specifically exempted. This requirement helps to ensure that electrical equipment is safe to use and that it meets minimum performance standards. Another important concept in the NEC is the concept of grounding and bonding. Grounding is the process of connecting electrical equipment to the earth. Bonding is the process of connecting different metal parts of an electrical system together. Grounding and bonding are essential for safety because they help to prevent electrical shock and to provide a path for fault current to flow back to the source. The NEC has detailed requirements for grounding and bonding, which must be followed carefully to ensure a safe and reliable electrical system. Overcurrent protection is another critical aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in a circuit when it exceeds a safe level. Overcurrent protection is essential for preventing fires and other hazards caused by electrical overloads and short circuits. The NEC has detailed requirements for overcurrent protection, including the size and type of overcurrent protection devices that must be used in different applications. Wiring methods are also addressed extensively in the NEC. The NEC specifies the types of wiring methods that are permitted in different locations and applications. Wiring methods include conduit, cable, and other types of raceways. The NEC also specifies the requirements for installing and supporting wiring methods, as well as the requirements for protecting wiring methods from physical damage. In addition to the general requirements for electrical installations, the NEC also has specific requirements for special occupancies, such as healthcare facilities, hazardous locations, and swimming pools. These special occupancies have unique electrical safety requirements due to the increased risk of electrical shock or fire. The NEC requirements for special occupancies are designed to address these unique hazards and to ensure a safe electrical environment. Healthcare facilities, as discussed earlier, are subject to the requirements of Article 517 of the NEC. This article covers a wide range of electrical safety topics specific to healthcare facilities, including grounding, bonding, wiring methods, and equipment requirements. The goal of Article 517 is to minimize the risk of electrical shock to patients and staff in healthcare settings. Hazardous locations are areas where flammable gases, vapors, or dust may be present. These locations are classified into different zones or divisions based on the likelihood of the presence of hazardous materials. The NEC has specific requirements for electrical equipment and wiring methods in hazardous locations, which are designed to prevent explosions and fires. Swimming pools are another special occupancy with unique electrical safety requirements. The NEC requirements for swimming pools are designed to prevent electrical shock to swimmers and to ensure a safe electrical environment around the pool. These requirements include bonding of metal parts, ground fault circuit interrupter protection, and restrictions on the location of electrical equipment. The NEC is a complex and comprehensive document, but it is essential for electrical professionals to be familiar with its contents. By following the requirements of the NEC, electrical professionals can help to ensure a safe and reliable electrical environment for everyone. The NEC also addresses energy efficiency. It includes requirements for energy-efficient lighting, motors, and other electrical equipment. By following these requirements, electrical professionals can help to reduce energy consumption and to save money on utility bills. The NEC is constantly evolving to keep pace with new technologies and changing safety standards. The NEC is updated every 3 years, and it is important to stay up to date with the latest edition. The National Fire Protection Association offers training courses and other resources to help electrical professionals stay informed about the NEC. In addition to the NEC, there are other standards and codes that may apply to electrical installations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. It is important to be familiar with these other standards and codes, as they may provide additional guidance and requirements for electrical installations. When planning an electrical installation, it is important to consider all applicable codes and standards. It is also important to consult with a qualified electrical engineer or contractor to ensure that the installation is safe and compliant. A qualified electrical engineer or contractor can help to identify potential hazards and to design an electrical system that meets all applicable requirements. Before starting any electrical work, it is important to obtain the necessary permits. Permits are required for most electrical installations, and they help to ensure that the work is performed safely and in accordance with applicable codes. The local building department or electrical inspector can provide information about the permit requirements in a particular area. During the electrical installation, it is important to follow safe work practices. This includes wearing appropriate personal protective equipment such as safety glasses and gloves, and using insulated tools. It is also important to energize circuits before working on them and to verify that they are de-energized using a voltage tester. After the electrical installation is complete, it is important to have it inspected by a qualified electrical inspector. The electrical inspector will verify that the installation meets all applicable codes and standards. If the installation passes inspection, the inspector will issue a certificate of compliance. Regular maintenance is essential for ensuring the safety and reliability of electrical systems. Electrical systems should be inspected regularly for signs of damage or wear. Any problems should be corrected promptly by a qualified electrician. Electrical equipment should also be cleaned regularly to prevent dust and debris from accumulating and causing overheating. The NEC also addresses the requirements for renewable energy systems, such as solar photovoltaic systems and wind turbines. These systems are becoming increasingly popular, and the NEC has specific requirements for their installation and operation. The requirements for renewable energy systems are designed to ensure that they are safe and reliable and that they do not pose a hazard to the electrical grid. The NEC also addresses the requirements for electric vehicle charging equipment. Electric vehicles are becoming increasingly popular, and the NEC has specific requirements for the installation of charging equipment. These requirements are designed to ensure that charging equipment is safe and reliable and that it does not overload the electrical system. The NEC is a living document that is constantly evolving to keep pace with new technologies and changing safety standards. It is important for electrical professionals to stay up to date with the latest edition of the NEC and to follow safe work practices to ensure a safe and reliable electrical environment for everyone. Understanding the nuances of Article 517 requires careful consideration of the specific healthcare environment, the types of procedures performed, and the potential risks to patients. Consulting with experienced electrical engineers and healthcare facility professionals is crucial to ensure compliance and maintain the highest level of safety.